My friends, welcome to my 203D CAD models in FreeCAD series. Today I want to work on exercise 187, which is a very interesting object. So I want to use this image in the background to help me sketching. Although with this 0.22 version, it is easier compared to 0.21 to draw and sketch without the background image. But since we have it, why not use it, right? So I set it up on XZ plane as you saw me doing that. So this is the XZ plane, that's where I want to start off. So I'll be building the whole thing with one sketch, and then these flanges, these triangular um, reinforcing plates, we will do that like a second sketch. With that, let's go ahead and relocate the image. Now because there is a tube, my first intention is to actually set everything up based on that one. But do you think that's a good idea? Especially given that on the second item, I'll have to draw this sketch. Maybe on this one, as an exception to my rule of thumb, I will build this model from here in the middle. That will help me sketch things easily. So that's like about in the middle. I'm gonna say good enough. Hit OK. All right. Now I want to start sketching on XZ plane. That's where this image is at. So it is important to match the sketching plane and where I want to have this image on. So I'll take the polyline and quickly draw the half of it. So I'll just take this and build the fillet in there. So if I can build the fillet within the sketch, sometimes it's not uh, suitable, but when I can, I feel like it's best, given that in the past I have had issues with fillets, and if I have it in the sketching, it's just nothing to worry about later on. One less thing to worry about. All right, let's make these 2 points coincident. Looks like it. And then I'm gonna take everything. Maybe I want to do it up to here too. So I want to do it up here, right? And then make a fillet between these two lines. So that's like a half sketch which I can mirror over. So double click on one of the lines and then mirror over here. Maybe before I do that, I can actually fix these lines with the dimensions. So this is right. Let's start with what we know readily. So this is 10. Somehow this is not matching. So let's go verify our calibration. Let's see. So this is should be 100. I did not do the verification, the calibration. All right, sorry about that. So everything stays same. I don't know how it happened. And then we'll have to obviously relocate again. So this will be at this point, right? I'm gonna go ahead and do that. Looks like a good match. That should do, right? And now we go back to the sketch and update our things. So this is going to be 40, and then this is 30, and this is 10. We don't have to do that because we already said this is 10 here, that, and actually we did the coincident constraint here. So that radius is, we don't have to do that, but we will have to do this. So what I'm going to do is I'm going to take these two and make it equal, and then bring it over here, right? And pull it all the way and say this distance is half the thickness. So this is going to be 5. Now that I have all these constraints given there, when I copy it over on the other side, they will be retained. So I take this mirror and it will be retained. Only thing I'll have to do is to make these 2 points coincident. All right, and then everything stays at the same point. Maybe I say this is, it's going to be 5, right? Yes, because half the thickness is 5. All right, and then, oh, I thought the dimension would be retained when they are mirrored over. All right, that's something that I learned today. Looks like the dimensions will not be retained, and I wish it did. Right. And now we have that part done. Let's go take care of this. So I will take a polyline. From here I want to say M, M, and M, and come here, and then so all the way this is going to be almost a circle, and do another M, M, M. Right. Maybe I delete this and bring this over there. So that's C for coincident. So this is going to be radius 10, which is same as this one. So let's go ahead and say E. So that's equal, and these two will be same as well. This is horizontal, and this is radius 25, diameter 50, and then this is radius 4, very small arc. And what else? This point, it's moving around. Let's go fix it. So the height of this point is 155 minus 35, so 120. And then the lateral distance is 40 or 45 because this 40 is given from the edge. All right, we have 3 degrees of freedom left, and one of them is this point. So this is horizontal, and then there will be a tangency T on the keyboard between these 2 points. There is already tangency there. We have 1 degrees of freedom left. I'm guessing this will be this length, and let's go fix this point. Looks like it has a dimension here, 140, so 105. Let's take that guess. All right, looks like it's a fully constrained sketch. Took us a minute, but we want to have it as a tube, so that's diameter 40. All right, we got that sketch. So this is, I'm going to say, sketch X Z plane, and then we want to extrude that for 60. So this says how much we should extrude it, obviously 60, and symmetric, and hit OK. Very cool. Now on to the next phase. I want to draw another sketch on XZ plane, and then so notice how this line comes all the way to the down to this point, to this edge. So this axis cross, this axis will not do us much good. What I want to do, I want to take a reference of this line, this edge, and this edge, which converts to a dot on this face. And I think I'll have to take reference of this edge and this edge as well. Right, now I can go ahead and turn on the section view, and then so let's draw from this point. I just want to do it. So maybe we should have set this axis cross initially at this point. That would actually help us uh, in this phase. Not a big deal, right? I want to go here and bring it over, not on that point. I just want to keep it on this edge and then bring it here. Now let's go ahead and make this horizontal, and then this point on this vertical axis is 80 millimeter from this one, so it's a 10 millimeters. That would be 70, I'm guessing. Oh, now it's 80, I'm gonna say 85, sorry, 85, because it is halfway through of this 10 millimeter. And that's a fully constrained sketch. Let's take a look at if it is coming down too much. It's not. So we can extrude that. So this is the mid flange, right? Or like stiffening or reinforcing part. And that is to be 10 millimeter pad of symmetric. And that's our object. All right, no, hold on. That is not our object. See how this edge comes around here? I'm just wondering if instead of taking this point, it would be actually tangential to this edge. So let's go back. Yeah, no, that's obviously not it. Let's delete this point, not the entire line, and delete this point. Now it is moving freely. So I want to take these 2 points and make them coincident. See, it didn't work. Take these 2 points, make them coincident, and then take these 2 points and make them coincident. And then we can say horizontal. Now we can go. What happened to that reference line? Let's hide this and hide this. And there should be 2 reference lines, right? We did take 2 reference. We did not. Let's bring the axis, this extrude back, and then I want to take this edge as a reference line and this edge as a reference line, and then hide that. And now I can go say this point is on this curve C, right? So take this point and this arc and C. All right, and do the same on this side. But I wanted to take this point and this arc C on the keyboard, and that's point on line constraint. And then I want to go hit T from this tangency and take these 2 edges. So that is one way to fix it. All right, and now one more things to consider. This 85 is from this axis, which is good. So we take this, and then like the exclusion is there. Now it looks like what it was asked in the technical drawing. So let's put them together as a fusion and say example 187 done. Now I have a question for you. If you consider this model in real life and say this is fixed surface, right? And then you have a cylinder going through here which is carrying load. So the load will be applied on this edge. Would you say this is a optimized design? How do you feel about these 2 flanges only covering this stem, and this part is like cantilever up here? So what do you feel about this model? Do you think it's optimized? Do you think there are more ways to improve it? Let me know of your thought. I want to do an FEM analysis on this model and an optimized model at a later date. So let me know what you think about it. So in that case, I'll be looking forward to having some suggestions from your side um, on how to optimize this model so that I can do some comparative analysis on FreeCAD FEM workbench. Looks like I forgot to add a couple holes at the bottom. So let's take a quick look at what we can do. Let me move it on the XY plane. And here our axis cross is right here. So the distance between this point and this point, maybe I take this sketch as my reference and start a new sketch on XY plane. And then I take reference of this line. So that will give me the end point. And I'm guessing other side will be symmetric to it. All right. So now I can go ahead and make a hole here. So 10 millimeter diameter. And then this distance will be 22.5. Right. And then the height is 15 from the outer skirt. We don't have reference to that. I think that's 15 from this base. Yes, that's 15. All right. And now we can take these and make an array of, so 1, and then we hit R one more time, and then take this center, come here, about here, and then move it here. So that's easy copy. Now I can go ahead and actually fix these. So this will be vertical, this two will be vertical, and then these two will be horizontal, H on the keyboard, and then these two will be horizontal, H on the keyboard. And then I can go make it symmetric by this axis, I'm gonna say. Somehow it didn't stay, so this is going to be vertical. All right, that's too much. Okay, so this, not vertical, this is going to be on the same horizontal plane. All right, so we got our sketch there, and let's take a look at the object, and that sketch is sitting, looks like in the middle. So we'll have to extrude it both up and down. So extrude that for say 25, for example, and then make it symmetric by the plane. And we can see that's poking out on each side, and then easily make a cut. And there it is. Well, my apologies that I missed it earlier, but it's there now. Thanks again for watching.